my name is Basir. In this video, I'll be teaching you Chapter 9, Differentiation from Intermediate First Year Mathematics, Telangana State and Andhra Pradesh syllabus. Now, why is it really important for us to understand differentiation? See, if you look at examination point of view, you stand a chance of scoring 22 marks in your intermediate public examination if you learn differentiation. And on the top of that, differentiation helps you in understanding some basic concepts like acceleration, velocity, and then slope of a tangent to a curve. Also, if you do not understand differentiation in intermediate first year, it will be very difficult for you to wrap your head around integration concept in intermediate second year. Now, differentiation, I see that most of the students, they kind of find differentiation overwhelming, and they kind of are scared of understanding or learning differentiation because it has a lot of formulae in it. I would say we only deal with algebraic functions like 2x, x power n, we deal with logarithmic functions like log x, and then we deal with trigonometric functions sin x, cos x, we deal with inverse trigonometry such as sine inverse x, we deal with hyperbolic functions like sine hx, cos hx, and so on. We deal with inverse hyperbolic functions like sine h inverse x, and then we deal with exponential functions like e power x. Now you must be assuming, oh my god, we have to deal with so many things to understand differentiation. Now you don't really have to worry because I have your back. I will first teach you all the formulae that you need to know before we move on to solving the questions from previous year question papers. Now, differentiation is a pretty easy concept. I would like to keep it as simple as possible. If you have any questions or concerns, you can always feel free to let me know your concerns or questions in the comment section. Okay, it's differentiation, believe me, it's going to be real fun for us to do it. So let's do this. Let us first sit down. We'll go through some formulae first so that we get ourselves prepared for solving any questions that have appeared in previous intermediate examination question papers. So let's get started. So before we start solving questions from previous year question papers, let us go through some formulae that comes handy when solving questions. Now first I will take you through a few formulae of differentiation with respect to algebraic functions, and then we'll go through few formulae of differentiation with respect to the trigonometric functions. We'll go through few formulae of differentiation with respect to the inverse trigonometric functions, and then we'll go through few formulae that involves hyperbolic functions, and then we'll go through few formulae that in which we deal with inverse hyperbolic functions. All in all, you would see that I have numbered the formulae here, and then we have about 30 formulae here, and then I came up with 2 more. So I have written this with a different ink here, probably blue color ink, just so I differentiate that these 2 are something that I pretty much came up with. But then you really do not have to worry about learning the formulae here. If you learn just one thing at a time also, let's say you go through these formulae on the first day, and then these on the second, these on the third, these on the fourth, and these on the fifth, it hardly takes you about 5 days to learn all the formulae. And these formulae are not difficult at all. Let us go through the formulae first, and let's get ourselves prepared before we start solving questions from previous year question papers. Now first things first, in differentiation you write something like this: d by dx, which means you are differentiating a function with respect to x, so I am differentiating the algebraic function x with respect to x. Now when you differentiate x with respect to x, you get 1. In the same way, if you differentiate y with respect to y, you get 1. If you differentiate z with respect to z, you end up getting 1. Now let's move on to the next thing. Now in this algebraic function, I have c, a constant here, and then I have x here. Constant, you always take it out of the differentiation. So constant c, I'm taking it out of the differentiation, and I'm left with only x here. Now x, if I differentiate with x, I end up getting 1. and then c into 1, that is c. Now in case you are not able to understand this, let me show it to you in a slightly different manner. Let us say I am asked to differentiate 5x with respect to x. Now I am differentiating 5x, which is an algebraic function, with respect to x. Since 5 is a constant, I am going to take 5 outside the differential. Now I am left with only x here. Now you would see for yourself, x, if you differentiate with x, you end up getting 1. 5 into 1, that gives you 5. Pretty simple, right? Now do not really worry, we'll learn differentiation one step at a time. We will slowly and steadily make sure we understand it well. Now let us say I have something like this here, d by dx of x power n. Power n, it goes in the front and then 1 gets subtracted from the power. Now you must be thinking, where can I apply this formula? See, applying this formula is pretty simple. Let us say I have something like this. I am supposed to differentiate x power 10 with respect to x. I am differentiating x power 10 with respect to x. What am I supposed to do? The power that you see here, the power, it goes in front of x, and then from the power 1 gets subtracted. 10 minus 1, that gives you 9. Pretty simple, right? So the power, it goes in front of x, and then the power, and then 1 gets subtracted from the power. Let us say I have something like this, d by dx of x power 7. What that should be? Power, it actually goes in front of x, and then 1 gets subtracted from 7. 7 minus 1, that gives you 6. So d by dx of x power 7 is nothing but 7x power 6. Now that is what it says here. The power, it goes in front of x, and then 1 gets subtracted from the power. D by dx of e power x. If you differentiate e power x with respect to x, you end up getting e power x itself. So d by dx of e power x is e power x itself. D by dx of log x is 1 by x. D by dx of a power x is a power x log a. D by dx of root x is 1 by 2 root x. I can pretty much prove this for you, but then it's pretty easy to learn this, so let's keep it this way. D by dx of root x is 1 by 2 root x, and d by dx of 1 by x is minus 1 by x squared. We'll use all these formulae, and then when we start using these formulae while solving questions from previous year question papers, I am sure you will have pretty good understanding of these formulae. Let's move on to the differentiation of trigonometric functions. D by dx of sine x is cos x, d by dx of cos x is minus sine x. So you can see here, differential of sine is cos, differential of cos is sine, but with a negative sign. D by dx of tan x is secant square x, d by dx of cot x is minus cosecant square x, d by dx of secant x is secant x tan x, d by dx of cosecant x is minus cosecant x cot x. I pretty much remember these formulae by thinking of the trigonometric identities. I'm sure you know there are 3 trigonometric identities: sine square x plus cos square x is 1, and then secant square x minus tan square x is 1, and then cosecant square x minus cot square x is 1. Right, so those are the trigonometric identities that we have. So differential of sine, I see that it becomes cos. Differentiation of cos, likewise, it becomes sine. And then if you differentiate tan, you end up getting secant, and then if you differentiate cot, you end up getting cosecant. That's how I personally remember these formulae. Let's go through these formulae once again. D by dx of sine x is cos x, d by dx of cos x is minus sine x, d by dx of tan x is secant square x, d by dx of cot x is minus cosecant square x, d by dx of secant x is secant x tan x, d by dx of cosecant x is minus cosecant x cot x. Let's go through these inverse trigonometric functions as well. D by dx of sine inverse x is 1 by square root of 1 minus x square. D by dx of cos inverse x is minus 1 by square root of 1 minus x square. D by dx of tan inverse x is 1 by 1 plus x square. D by dx of cot inverse x is the same thing as tan inverse x but with a minus sign. If you pretty much have a close look on these formulae as well, you would understand d by dx of sine inverse x is 1 by square root of 1 minus x square. D by dx of cos inverse x is just the same thing but with a negative sign. The only difference here that I see is I just see an additional minus sign when I take the differentiation of cos inverse x. Likewise, if I look at the differentiation of tan inverse x and cot inverse x, I see that they are pretty much the same thing, 1 by 1 plus x square, 1 by 1 plus x square, but with a negative sign here. That's about it. D by dx of secant inverse x and cosecant inverse x, they are actually the same thing, 1 by mod x square root of x square minus 1, 1 by mod x square root of x square minus 1 with just a minus sign here. Let's move on to differentiation of hyperbolic functions. Now remember, sine x is a trigonometric function, but then sine hx is a hyperbolic function. D by dx of sine hx is cos hx, d by dx of cos hx is sine hx, d by dx of tan hx is secant h square x, d by dx of cot hx is minus cosecant h square x, d by dx of secant hx is minus secant hx tan hx, d by dx of cosecant hx is minus cosecant hx cot hx. And then you have differentiation of inverse hyperbolic functions. This I will skip it for now because we hardly make use of these formulae, but then at least you should be good till here. Now, don't really get afraid of learning the formulae. We will eventually start learning the formulae when we start making use of these formulae while solving questions from previous year question papers. Now, before I move on to solving questions from previous year question papers, I would also like to acquaint you with something known as the product rule, and then I would also like to talk a little bit about the quotient rule, and then probably I would also like to talk a little bit about the chain rule. So these are quite a few things that you need to know to be able to start solving questions from the previous year question papers. Now, product rule. What is product rule? Let us say I'm asked to differentiate something like x sine x. Let us say I'm asked to differentiate x sine x. Now, you would understand that this x that you see here, it is actually a function. It's an algebraic function, right? An algebraic function is a function in which you have variables and constants, something like this. You have a variable x and then you have constants like 2 and 3 and so on. So this is an algebraic function. And then this that you see here, sine x, is a trigonometric function. So I have two functions here, that an algebraic function which is in x here, and then a trigonometric function which is also in x here. Now let me write here, let us say this is a function u of x. I'm writing x here because this is a function in x, and then I have another function v which is also a function in x. So that's an algebraic function and that's a trigonometric function. Both of them are functions of x. Now what do I do when I have something like this? Now you would see that, how do you read this? You read it as x sine x. X sine x is nothing but x into sine x. X into sine x. There is an invisible multiplication operator here, x into sine x. So that's where the product rule comes handy. That is where the product rule comes handy. Now when you are asked to differentiate something like x sine x, where obviously the first one is a function of x and the second one is also a function of x, and they are obviously in multiplication, so you have to use the product rule. And how do you use the product rule? Using product rule is pretty simple. Let me put it this way. Let us say I am supposed to differentiate two functions. The first function I'm denoting it by u, which is a function of x, and then I have another function, I'm denoting it by v, which is also a function of x. How do you differentiate this thing? How do you use the product rule? Using product rule is pretty simple. The first function that you see, keep it as it is, differentiate the second function, v of x, and then keep the second function as it is, differentiate the first function. So this is pretty easy. I am first removing the first function, differentiating the second function, and then I am keeping the second function aside and I am differentiating the first function. Now you must be really confused, what am I really doing here? Now this thing that I have written here, there are a lot of ways of writing this. There are people who write it in this manner also. Let me show you. Let us say I have a function here. Let me use this page for you. Let us say I have a function in x and then another function in x, and I'm supposed to differentiate it with respect to x. Now there are a lot of ways of writing it. People write it in this manner also. Instead of writing d by dx, they keep a dash here, dash, which is nothing but the differential of this thing. The differential first goes to, let us say, vx, and then the differential goes to ux. That's how you can write it. But then let me try to keep things simple for you. Let me try to differentiate this thing for you using the product rule. If I have to differentiate x sine x, if I have to differentiate x sine x using the product rule, this is what I would really do. I will keep x aside, differentiate sine x, and then I will keep sine x aside and I will differentiate x. So do you really understand what am I doing here? I am keeping x aside and I am differentiating sine x. Keep a plus sign and then do the reverse of it. Keep sine x aside and differentiate x. What happens when you do that? This x which I kept it aside, it remains as it is. D by dx of sine x. What is d by dx of sine x? Let's go back and check here. D by dx of sine x is nothing but cos x. So in place of d by dx of sine x, I'm going to write cos x. And this sine x which I kept aside, I'm going to write it as it is. D by dx of x. X, when I differentiate with x, I end up getting 1. You can see for yourself. We went through this already. X, if I differentiate with x, I get 1. So now x into cos x is x cos x plus sine x into 1 is sine x. So the differential of x sine x is x cos x plus sine x. So this is what you get when you differentiate x sine x using the product rule. Pretty simple, right? Now let us say I have something like this, x plus sine x. Now remember, you have a plus here. It's not a product anymore. If it's a product of two functions in x, then you use the product rule. You keep one function aside, differentiate the second one, and then keep the second one aside, differentiate the first one. That is how you make use of product rule. But here I have a plus sign. You may have a plus sign, or let's say you have a minus sign. When that happens, you cannot use the product rule because it's not a product of two functions in x. In this case, what do? You kind of use the distributive property. You distribute d by dx to x also, and then you distribute d by dx to sine x also. I'm trying to keep things as simple as possible here. When you differentiate x with respect to x, you end up getting 1, and then when you differentiate sine x, you end up getting cos x, isn't it? So your answer would be 1 plus cos x or 1 minus cos x, depending on what sign you have here. Let us say you have something like this. Differentiate, let us say I'm supposed to differentiate 5 sine x. Now I have seen most of the students, they kind of go wrong with the product rule, and then they tend to apply the product rule here, which is really wrong. Why? Because this is 5, which is not a function of x. I don't see any x here. It's not a function of x. I only have one function of x, sine x, which is a trigonometric function. This is the only thing that's a function of x. This is not a function of x. In this case, since this is a constant, you are supposed to kind of take out the constant out of the differential d by dx, and you are left with only sine x. So you just have to differentiate sine x in this case. D by dx of sine x is cos x. So your answer would be 5 cos x. I hope you are pretty clear with the product rule now, where to apply product rule and where not to apply product rule. And Do not really worry. As we move forward with solving questions from previous year question papers, you will understand product rule in a very better manner. Now, since we are talking about the product rule, instead of having two functions of x, let me take three functions of x. Let us say I have three functions of x. Instead of just taking two functions of x, let me take three functions of x. Let us say I am supposed to differentiate x sine x e power x. Now, you have to agree that this thing that you see here, the first thing x, it's an algebraic function. Let me denote it by u. It's a function of x. And then sine x is a trigonometric function, which is a function of x. Because I see x here, let me denote this second function by v. And then this e power x is again a function of x. This is an exponential function. Let me denote it by w. So if you have three functions of x like this in product, what you really do is, let us say, okay, let me write it here so that you get a pretty good understanding of this. So let us say I have to differentiate u, v and w. All of them are functions of x. So let me specify here, u is a function of x, v is also a function of x, w is also a function of x. When you have something like this, what do? You differentiate u, v and w, keep them aside. Next, differentiate v, and then next differentiate w. That's about it. So what did we do here? First we differentiated u, and then we differentiated v, and then we differentiated w. That's about it. Very simple. Let's try this. Let us try this. So what am I going to do? I'm first going to differentiate x, and then keeping these two as it is. Second time I'm going to differentiate the second one, keep the first and third one as it is. Third time, differentiate the third one, keep the first two as it is. So this is what I would pretty much do here. I'm going to differentiate the first one. The next two, I'm going to write them as it is. The next time, I'm going to differentiate the second one. The third time, I'm going to differentiate the third one. d by dx of e power x. So I'm differentiating the third one, e power x. Now what would my answer be? When you differentiate x with respect to x, you end up getting 1 sine x e power x as it is. This x is as it is. When you differentiate sine, you end up getting cos, because d by dx of sine x is cos x. And then when you differentiate e power x, you end up getting e power x itself, because d by dx of e power x is e power x itself. So you have differentiated this thing and you got your answer as e power x sine x plus x e power x cos x plus x e power x sine x. Pretty simple, right? Let's move on to understanding the quotient rule. Let us say I have something like this. I have something in the form of a fraction. Numerator is a function of x, and then the denominator is also a function of x. When you have to differentiate something like this, this is what I personally do. I would keep the denominator aside, differentiate the numerator, keep a minus sign. This time I'm going to keep the numerator aside and I'm going to differentiate the denominator by square of the denominator. In case you do not understand this, let me take an example so that you get a clear picture of this. Let us say I am supposed to differentiate something like this. Let us say I am supposed to differentiate x by sine x. Now, you see that the numerator here is a function of x, and then the denominator is also a function of x. Numerator is an algebraic function, while the denominator here is a trigonometric function. So, when you have something like this in the form of p by q, the quotient rule comes into picture. What do you really need to do? Keep the denominator sine x aside, differentiate the numerator, keep a minus sign. This time keep the numerator aside and differentiate the denominator by square of the denominator. That's about it. Pretty simple. There are people who kind of learn this thing in this manner also. U by v, when you differentiate it, you get vu dash minus uv dash by v square. There are a lot of ways in which people remember this. Here also you are doing the same thing. You are keeping the denominator aside, differentiating the numerator. When you differentiate u, you end up getting u dash. Keep the minus sign, keep the numerator aside, differentiate the denominator. V, when you differentiate it, you get v dash by square of the denominator v. That's about it. Let us see what we end up getting here. X, when I differentiate it with respect to x, I end up getting 1. D by dx of sine x is nothing but cos x by sine x whole square is nothing but sine square x. I hope you know the square, you can write it here, sine square x. So this is what I get. Sine x into 1 is sine x minus x cos x by sine square x. So this is what we get when we differentiate x by sine x using the quotient rule. So the quotient rule is pretty simple here. You keep aside the denominator, differentiate the numerator, keep the minus sign, keep aside the numerator, differentiate the denominator by square of the denominator. Now, I told you I will talk about 3 things before I start solving questions from previous year question papers. We already talked about the product rule, we talked about the quotient rule. Let us now talk about the chain rule. I wanted to keep things very simple for you so that you understand differentiation very well. So I am going to make use of chain rule a lot while solving the questions. When I say chain rule, this is what I pretty much mean. Let us say I have something like this. Let us say I'm supposed to differentiate something like e power sine x. Let us say I am supposed to differentiate e power sine x. How am I going to differentiate e power sine x? Now when I go back to the formulae, I don't see a formula for e power sine x. Do I get to see a formula for e power sine x? I don't think so. I only have a formula for e power x. When I differentiate e power x, I end up getting e power x, the same thing. D by dx of e power x is e power x. But I don't see a formula which says d by dx of e power sine x. I don't see it here. So this is what you pretty much have to do. I know that d by dx of e power x is e power x itself, but I don't know how to differentiate e power sine x. In that case, let us consider this sine x as x itself. So in your mind, you can consider this sine x as x. Now d by dx of e power x should be e power x itself, where I assume sine x is x. But is sine x x in reality? No, it is not. Sine x is not x. So what are you going to do? You are going to differentiate sine x as well. So this is what I mean by chain rule. So you differentiate the first thing by assuming that this is x, d by dx of e power x is e power x. But then since this is not x in reality, so you have to differentiate that thing as well. So what are you getting here? E power sine x. When you differentiate sine x, you end up getting cos x. So when you differentiate e power sine x, you end up getting e power sine x cos x. Now if you don't really get a hang of what chain rule is, do not really worry, because I am going to make use of chain rule extensively when I keep solving questions from previous year question papers. So you will obviously eventually slowly and steadily get a hang of it. Do not worry. Okay. Well, so we saw a few formulae here, and I will upload all the formulae in the form of a PDF document in my Google Docs, and I will provide you a link to download those formulas so that the formulae will be handy with you when we start solving questions from previous year question papers in the next video. And remember the fact, if you stay with me for the rest of the video series, you will be able to master differentiation in no time. So I'll see you all in the next video. Until then, goodbye.